Hi, welcome to the second course of the neural networks. So in the previous video, I've shared that we need to create some kind of mathematical representation of input weights such that when the input is multiplied with the weight, we get the expected output. So let's dig a little deeper on how do we do that. Let's take this as a hypothetical example of 10 images, and let's say we created some random numbers in the weight matrix. This might be as simple as 0, 1, 2.5, 77.2, etc. Okay, and we have this constant weights. I mean, this is a fixed matrix. This matrix has fixed values, and we multiply our images with these values. Now let's assume that this multiplication is really well defined such that we get outputs in terms of zeros and ones. So the predicted output is this one, where the first one, for the first image, the prediction is 0. That means the dog is not present in this image. And for the second prediction, for the second image, it said that the dog is present, and so on. So if you could see, then this neural network model predicted that only 1 out of the 10 images contains dog. And let's look at the actual values of these images. So the first image does not contain dog in it, and the second image contains dog in it, and so on. So when we try to see how well the neural network did, you can actually see that there are 5 images that have dogs and 5 images that don't have dogs. Our model predicted to have 1 image that has dog and 9 images that does not have dog. So if you could just look at its metrics, something to start with, we can say that our neural network is 60% accurate because out of 10 images, it predicted 6 images correctly. But here's a catch. Now, if you randomly take, if we randomly predict every image to be a dog image or to not be a dog image, then we will be able to predict 50% of the data correctly because just 5 images contains dogs. So if you do a random guess, you will be 50% of the time right. So the neural network is adding just 10% value. That is, it is slightly better than a random model or random prediction. So this is a good or great starting point, but this is not where we want to end up. This is not a product that we can use it to classify the images. So what can we do next? The next immediate step is tune these weights. What I mean by that is change the weights in this matrix such that your prediction is slightly better. Maybe, the model gets a little better in predicting. And not just little better, it should get a lot better. So the only goal here is to change values in this matrix. Why is that? Because we can, hypothetically speaking, we cannot change the values of the input that is fixed. We can transform and standardize, and we can use some couple of pre-processing steps, but there's not really a lot of chance there. So the only change that we can do here in this equation is change the weights such that your predicted output gets closer to the actual output, right? So so that is the process. We call it training, or backpropagation, or um, yeah, epochs or iterations. So basically, we want to learn a systematic methodology in which we can change these weights so that our predictor gets closer to actual. And there's this amazing concept known as backpropagation. Propagation. While I don't want to dig into specifics here, but on a very high level, what could we do better on changing this weight matrix, right? One way to do that is to start adjusting these values, and you should adjust these values in such a way that your prediction should be better. So let me think on how can we do that. One way to do that is actually look at our loss. So what do we need? At the end of the day, we want the loss. Sorry, this will be a loss. Let me write it in x-axis way. This will be a loss. So we want the loss to be as minimum as possible. So you have to change the weight change. Such that over the process of changing the weights, your loss reduces or your loss minimizes. So this could be a good standard. So backpropagate. So change weights such that loss is minimal, right? This is our ultimate goal, and in order to achieve that, we will be walking through a space of these random numbers that we call weights and try to slowly figure out an iterative methodology in which changing the weights could help reduce this loss. So let me take another example in which we have loss. And let's say when you and this is our x, or we call it as weights. Let's say weights. Okay. Now, with having one set of weights, we got a loss of maybe something around 10. And then we tweaked our weights a little. We got a loss of 9. And then we tweaked the weights a little more. We got a loss of 12. So let me draw a graph here. So basically, at different weights, we are getting different losses. Okay. So in this methodology, we should find the exact weights that we can use so that our loss is minimal. These are the set of weights, our minimal loss. So in order to achieve this, we need to find one way of, this is our starting point. This is some weight that we started, starting weight. We need to change our weights at some fashion or in some methodology such that we hope we eventually reach to this set of weights. And this can be achieved through backpropagation. So backpropagation is basically derivating the weights such that the loss is minimized. So in order to do that, we use a very well methodology known as gradient descent. We will discuss about this in future, and we will discuss about this in future. And thank you for joining this lecture. Have a great time. Bye.